Hi and welcome to another DCG tutorial slash drawn or whatever you want to call this. So today we're going to do 2014 B-2, an axonometric question. Alright, so figure B-2 shows an incomplete trimetric projection using an axonometric axis method of a model of a basketball backboard based on a 3D graphic on the right. So the elevation and view are shown in their required positions. So A, draw the axonometric axis X, Y, Z and the scaling triangle ABC. Draw the elevation and end view orientated as shown and complete the trimetric projection. And C, draw an axonometric projection of a basketball in contact with the backboard at point P. Radius of the ball is 12 mil. Alright, so these axonometric trimetric questions, they're nice questions, and if they come up as a long question in section B, then it's great, because half the question is done out for you on the actual page. So start off part A, draw the axonometric axis X, Y, and Z and scaling triangle ABC. So looking at the question, obviously you're going to have the elevation to the right, end view to the left, and your 3D in the center. So I'd start low enough and in the middle of the page, alright? So start off, what I'm going to start off is up my y-axis, going straight up. And I'm going to use my adjustable set square to get the angle. So the angle is 110, so I set it to 20 to get that full 110 here to the left hand side, and the same to the right. Okay, so I'm going to draw my light lines a bit stronger in this question, just so they might show up a bit better. Now, to figure out the scaling triangle ABC, you need to use the measurement to the left and to the right. So in this case, it is 50 mil. So we measure, 50 and 40. So we measure 50 mil and 40 mil, and draw them lightly down. We'll get our point A and our point B. Okay, so again, you always label as you're going along. So label this fella here point A, and this one point B. And then to find point C, if you look at the question, look at your green lines, look at the construction lines, there is perpendicular symbols there, so use them as well. So if we go perpendicular to our axis from A, so that's the axis there. So if I go perpendicular to that, which would be, let's figure out this one here, that angle there. If I go perpendicular to that axis and draw it up from A, we'll be given point C. Okay, so join them all up. And now that we have a bit of an idea where our drawing is going to go, I'm just going to label the axis as well. So first things first, let's put in the elevation, because that's one of the most detailed. The end view then there isn't too much to do. So I'm just going to move the page over so you can see exactly where I'm going. So to do the elevation, you're projecting over here to the right, you're projecting parallel to the z-axis. So you use that z-axis, extend out your point A. Now to find where to start to draw, you also need to project out points C and B. So project out point C, project out point B. So once you project out point C and point B, now we have a fair bit of room over here, and we don't want our drawing to interfere with the 3D. So draw a line, and I want to make sure it stays on the drawing here as well. Draw a line perpendicular to those projection lines, so that you cross the C and B lines. So this line here, so project it out perpendicular, that's the C line, that's the B line there. Bisect that line to find a center point and to be able to draw in a semicircle, okay? So bisect that line and that will give you the center. And it's from that center you draw your semicircle, so pin here at the center, lead right out at the edge. And where this semicircle crosses the Z-axis here, that gives you the angle for the elevation, okay? So the corner of the elevation basically. So by joining back down from here into there, and joining back the B line there to that corner, we are now given the angle for which to draw our elevation. So this is our angle of the elevation, so let's draw the elevation as normal there. And again, just to make it quicker, I'm going to set up the adjustable set square so that I got my angles right. So we have heights first, we have 10mm and 40mm. 10mm, 40mm. You can draw them lightly across. Okay, so there's no length across. What they are giving you is B is the center. So bring point B up. B is the center point for that radius. So, and the only point on the radius is that height force there. So I put the pin at B, lead at the height. So pin here, lead at the height, and I draw my semicircle or my arc around, and where that cuts the same height measurement, that 40mm over on the right hand side here. So just push this over so you can see. That tells me how far over the basket or the backboard is going, so I need to draw that straight down. Okay, so stopping at the 10mm there, and it is from that B line, so we'll just put it center line right up to the top there. It's 40mm. 40mm is width of the square on the backboard, so we'll just measure, center that there. So we go 20 to the left, 20 to the right, and use your adjustable set square again to draw that right up. And we have everything we need there to draw on the elevation. So I'm going to draw it in strong, just so you can see it a bit better. That is the elevation done and drawn in strong. So now we can move over to the end view. So I'm just going to forget about that elevation for 2 seconds, just move it over here and we'll focus on the end view. So again, the end view is being projected from a certain angle, so it's the x-axis this time. So again, set up your angle. So good from the x-axis here. So project up your x-axis, project up point C, and you also need point A this time. I know, looking at the question in the book, looking at the actual question, that the 3D is going to be over here to the right hand side. So we can put in our corner nice and close to the side here. So that's my projection line. So I'll go perpendicular to it. Should be around here. Same procedure as the elevation. Bisect it. So seeing as it's a backboard for a basketball rink, the measurements are just heights, and it's a line drawn there. So again, you have your 10, you have your 40, and they're actually showing you. So let's measure that up first. So you have your 10, you have your, and then your 40 on top of that. Alright, so just mark them in, and it's showing you that the height is the full height from the base here up to the top there, which was our radius. So rather than going measuring, I'm just going to get down the compass. Alright, that's our full height. Mark that in over here, and that's our backboard, drawn and strong. Okay, so labeling is always key in a question like this. So I'm going to label the main outline points of the elevation. I'm going to leave the curve to the end. I'm going to mark in the 4 points here of the square on the backboard. Alright, so we'll go with these first. So we'll go with letters for these. So yeah, we'll still go with A, B, and C, D, even though they're here on the point. So this is point A, point B, C, and D. A is 50 mil up, so therefore the 50 mil up mark here that you did there when you're drawing the end view, this is going to be point A and D. Alright, so we'll do them in the front here because they're in the front, A and D. Same thing for the 10 mil, it's going to give you B and C. This point here is B and C. Now let's label the outside line. So this is point, we'll go point 0 here, point 1, 2, 3, 4, 5, and we'll leave the rest of the points up. Actually, we'll leave that point now to the end. We'll just do points 0, 1, 2, 3, 4, and 5 first. So 0 and 5 are on the same 50 mil light up here. So this is point 0 and point 5. 1 and 4 are the same height as B and C. So this is point 1 and 4. And then 2 and 3 are right down on the base, right down here. So this is point 2 and 3. So for axonometric projection or any of these trimetric projection, you project from the elevation and the end view. You project from your two views into the center, and where the points meet give you where that point will rest in the view. So let's start off with the outline first. So 0, 1, 2, 3, 4, and 5. So, and they are projected at the same angle as the axes themselves. Alright, so Z was the axis that was used to project up. I'll just adjust this now, it's a little bit off. Not so bad. Z was the axis used to project up the elevation. So project 0, 1, 2, 3, 4, and so on down at the same angle as Z. So we're going to do point 0 first. So 0 comes down here at this angle. Where is 0 in your end view? It is here, again projected down same angle. Now wherever they meet will be point 0 in your 3D view. In this case it should be resting there on the y-axis, so this is point 0. Do the same with 1, 2, 3, 4, and 5. So Alright, so there you have 0, 1, 2, 3, 4, and 5. Okay. So let's draw them in strong. Now, part C, the question might be going over, but it doesn't matter, we're going to draw in strong anyways, just so it stands out. Now, let's mark in A, B, C, and D. So, A is on the same height as the 0, 5, so that is A here. B is on the same height as 1 and 4, so that is B here. Okay, so let's bring down D now as well. So this is D. Let's point D here now. And they're going to be firstly straight down, so this will give you the height for C. And this is point B. Now, part C might be going over that, so we're not going to draw them in strong, we're just going to draw them in lightly. Now, the next part is going to be our curve, so we need points going from 5 over to 0. So in order for your height to translate from the elevation and the end view down to the trimetric view, you need to figure out how to split it up. So if you were to divide up the circle 30, 60, how are you going to do the same in the end view? Okay, so that's not going to work. So what you need to do is, what was working here is height. So see the heights up there, that's 10, that's BC, up 40, that's AC. So these heights are translating over to the end view. So you need to use height to mark in those points. Okay, so horizontal cutting plane. So if we measure up, let's figure out what the height is here. So it's roughly 30 mil. So if we go up 5 mil, 5 mil, 5 mil, we'll get plenty of points to draw it in free. So 5, 10, so 1, 2, 3, 4, 5. Yeah, that should be enough, and that should be loads. So what I'm going to do is, from point 0 here, measure up 5 mil, 5 mil, 5, 5, and the last 5 there. And we'll just use whatever the height is left. Draw those cross slightly. I'm going to put in with a colour here just so they stand out. You don't need so many points, but the more the merrier. So that will give you points. Actually, let's skip 2. So let's go up here and there. That should be plenty. You do it whatever measurement you want, so it's up to you. So let's go with 0.6, 7, 8, up at the top here at 9, then work our way back down. This is 0.10, skip 1, this is 0.11, and then little one here then 0.12. Okay, so because it's height, those heights can translate now from AD up. So mark in, so we went 5 and then we went 10 and 10. So mark in those heights here on your end view. So 5 mil was the first height, then we went 10 mil and 10 mil. Alright, and that's going to give you the heights for, this is 6 and 12, next one is 7 and 11, and then this is 8 and 10, and the last point up here is 0.9. Okay, so if you project those heights from the end view down and from the elevation down, it'll give you your 1, 2, 3, 4, 5, 6, 7 points. Join them in freehand lightly. So once you found all your points, join them in freehand lightly, and then you can go over strong. Now the last part is part C. So we have to find a point P in the elevation in the plan and draw in the basketball, which is radius 12 mil on that point. So let's find point P first in the elevation. I showed you joining the diagonals A to C, B to D to find the center point. So here is point P. How do we find that point in the end view? Again, height. So because there's an line view there. So find the height up to point P, mark that in the end view. Okay, I'm going to use the compass. So this is the height for point P. Okay, so it's resting on point P. So, and if it's radius 12, it means the center would have to be directly in front of P if this is the elevation. Okay, so P is the center there. Let's draw in our radius 12. Our radius 12 circle. So this is okay, so that's our basketball there in the elevation. Find it from the end view. So if it's resting on point P, it's kind of like solids in contact. If it's resting on point P, then you need to project out perpendicular from the backboard. And if it's touching point P, then the center will be the distance of the radius out. So this is the radius 12. So put in your basketball then resting against that surface. That will give you the center of the basketball in the end view. The reason the center is so important is because spheres will always be proper circles in axonometric. So if we bring the center point down to the axonometric view, bring the center, which is point P, down from the elevation, that'll give you the center here, drawing your radius 12. That is part C of the question done. So now we can draw the resting strand then. So okay, so that is the question done. A, B, and C. Nice question if it comes up as part B, where you can actually have the majority of the question on the sheet in front of you. It's just a matter of remembering how to put in the angles for the elevation and the end view. Okay, so hope you liked that question, hope it helped. If it did help, leave a like, and if not, please leave a comment. And as I said before, I think the annotations are better where you actually have the annotations in the video rather than the commentary, but let me know what you think. Okay, thanks and good luck.